Hello friends, this video is for third semester physics student of Dibrugarh University. Okay, here we're going to solve the paper of mathematical physics which is C5, right, of 2021. Okay, so exam was held in January or February here 2022. Okay, this is part 1. So I'm going to complete this paper in 5 or 4 parts. Okay, so let's start. Now this is the first question. So what is the value of complementary error function of x plus complementary error function of minus x? That is 2. Let me show you how. There is a property that error function of x plus error function of a complementary error function of x, sum of these two is equal to 1. So in that case, what we can write that applying this rule here, what we can write, this complementary error function of minus x, that's going to be equal to 1 minus error function of minus x, right? Okay, just replace this x by minus x, then this x should be also replaced by minus x, and this term is transferred to other side, so we have got this result, right? So we can replace this one. So let me show you error function. Just wait. This is error function, complementary error function of x. Then I have written this one as 1 minus error function of minus x, right? Because error function of x plus complementary error function of x is equal to 1. So here you can see, from this we can obtain error function, complementary error function of x is equal to 1 minus error function of x. So if you replace this minus x, this x by minus x, then this x must be also replaced by minus x. So we have got this result, right? Now you can see that error function of minus x is equal to minus error function of x. There is another property, so that's why what we can write here, that error function, complementary error function of x 1, and this must be minus error function of x, right? And this minus, that's going to be plus. Okay, that's going to be plus error function of x. Now again you see error function of x plus complementary error function of x, that is equal to 1. Then this 1 plus 1, that's going to be 2, right? That's how we have got the answer. Okay, so if you want to learn about error function in details, I have given an video link in the description box. Okay, I have written there error function, then the video link is there. Okay, just click that and go watch. Now what is the value of gamma minus half? We know that the gamma function of n plus 1 is equal to n gamma n. So now replace the value of n by minus half, then what we're gonna have now? So minus half plus 1 minus half gamma function of minus half, gamma of minus half, so which can be written as this gamma of minus half plus 1, that's going to be plus half. So we can write here gamma of plus half minus half and gamma function of minus half, right? So multiplying both sides by minus 2, we're going to have minus 2 gamma of half. On the other side, we have multiplied minus 2 on both sides, we're going to have gamma of minus half, right? So therefore gamma of minus half will be equal to minus 2 gamma of half. Gamma of half is nothing but square root of pi. Gamma of half, this value is square root of pi. So that's why our answer is this. This is your answer, right? So hope you have understood this. Now let's move on to next question. So find the value of Legendre polynomial P2 of x. Okay, how to find its value? First, let me clean these things. Okay. So let me show you here. So we know that Pn of x Legendre polynomial, that is given by 1 by factorial 2 into factorial n, sorry, not factorial 2, 2 to the power n into factorial n, and nth order derivative with respect to x of x square minus 1 whole square, right? So we need to find P2 of x now, right? P2 of x now, that's why replace the n by 2, then you will get here 2 square and 2 factorial second order derivative with respect to x of x square minus 1 whole square, right? So here you see this is gonna be equal to here you can see 1 by 2 square, and factorial 2 is nothing but 2 into 1, and if you differentiate it once, then what you will get 2 into x square minus 1. Then again if you differentiate the part within bracket, it is function of function, then you must have got twice x, right? So here you see 2 to the 4, which is equal to 2 square, cancels, right? So what we have got now, we have got that 1 by 2 x square minus 1 into x, right? We have got this. So now here you see we have differentiated this once only, so we have to differentiate it again, right? So because here you can see we have second order derivative here, just differentiate it again. Okay, if you differentiate this again, then what you will get, so let me write it clearly. So you must differentiate it again. So 1 by 2 derivative with respect to x of, if you multiply x with this, then you must have got x to the power 3 minus x, right? And if you differentiate it, what you're gonna have, you're gonna have 3x square minus 1. That is our answer, right? So here the correct option is this. So this is our answer, right? So hope you have understood. So this is our next question. There is a differential equation. Okay, so we should we must know what type of equation is this. This is Legendre's equation or Bessel's equation, Lagrange's equations. Okay, Lagrange's equation or Hermite's equation. Which one is correct? So that is Hermite's differential equation. This is Hermite's differential equation. Okay, so now you see your option is fourth option is correct. This is your answer, right? Now let's move on to the next question. So here you see, to answer this question, the sum of this series, so you must know the Fourier series expansion of this function. Okay, x plus x square, right? So if you have practiced various type of functions in Fourier series, then you must have got. So here the answer is this. Okay, so you know how to find the Fourier expansion of given series. In order to find that, if you want to know, if you want to learn Fourier series, I have made many videos on Fourier series. Okay, I have provided links of the playlist, link of the playlist of Fourier series in description box. If you want to watch them, then you can go. Okay. And I will show you that how I have got this pi square by 6. At the end of this video, I will paste a photo of this solution. Okay, so now let's move on to the next question. This is question number 2. So these things are also discussed in Fourier series. Okay, I will give another link in the description box, writing this way: question number 2, and here will be the link. Okay, and click that link, you're gonna get the answer of this question. Okay, now expand the function f of x is equal to x sin x in Fourier series in the interval minus pi to plus pi. Hence, so this, right? So now you see, first we need to expand this function in Fourier series. Okay, so here the given function is that f of x is equal to x sin x. Okay, and Fourier series, let its Fourier series be f of x, its Fourier expansion be, let me consider a naught by 2. Okay, plus summation n is equal to 1 to infinity, 1 to infinity, just an cos n x plus n is equal to 1 to infinity bn sin n x, right? This is suppose equation number 1. Okay, just let me do a little bit of adjustment here. Okay, just wait. And what does an and bn mean here? So if you want to know these things in details, you can go to the video series, and I will show you here how to solve this problem. This is very simple, not so hard and not so tough. Okay, now you see. So what is a naught here? How to find a naught? So in order to find a naught, we can a naught is equal to 1 by pi from minus pi to plus pi f of x dx is equal to, you can change the limit from minus pi to plus pi into 0 to pi. In that case, you have to write 2 pi 0 to pi f of x dx, right? And similarly, there is an is equal to, you will get 1 by pi minus pi to plus pi f of x cos n x dx, right? And it also can be written as 2 by pi, and this will be changed to 0 to pi f of x cos n x dx, right? And here bn is 1 by pi minus pi to plus pi f of x, here sin n x dx, and this also can be written as 2 by pi minus pi to plus pi f of x sin n x dx. Okay, now let me go to the next slide. Okay, let me write these things properly. Okay, just wait. So now here you can see these are the values of a naught, an and bn. So let us find one by one. And one more important thing, so what kind of function is this? You can see here f of x sin x. Okay, So if you put f of minus x, if you replace the x by minus x, then what are you going to have? Minus x and sine of minus x. We know sine of minus x is minus sine x. So in that case, this minus and this minus, it will be plus. So that's going to be equal to x sine x, right? And x sine x is nothing but your f of x. So since f of minus x is equal to f of x, therefore f of x is even function. And in case of even function, let me write this one. And in case of even function, value of bn is 0. Value of bn is equal to 0. Okay, we don't need to evaluate it. So this must be equal to 0. Value of bn is equal to 0. So here we can write, therefore bn must be equal to 0, right? So that's why this equation number 1 reduced to this. Just wait only. So we have got now f of x is equal to, so this equation number 1 just reduced to this form. So this is equation number 1 now. Putting bn is equal to 0, we have got this. So let us take this as equation number 2, right? So we have got bn is equal to 0 because f of x in this case, the f of x in the given function in this case is even function, and for even function bn is equal to 0. Now let's find a naught. Now how to find that? As I have already shown that a naught is equal to this, right? Either this one or that one, you can apply both, any one of these two. So here 2 pi, this f of x is nothing but here x sine x, right? So now let me write dx. Okay, x sine x. If you integrate x sine x dx, then what are you gonna have? Just apply this rule, integration u v, u integration of v, v1 means integration of v, right? Then minus u dash means first order derivative of u. So hope you know these things, that is u dash. Okay, then v2 means integration of so let me clean this. v2 means integration of v1. Okay, then again plus second order derivative of u, then v3 and so on, right? Dot dot dot. If you apply that, taking this one as u, right, and this one as v, sin x as v, then this must be equal to u, that is x, integration of sin x is minus cos x, right? Then minus derivative of x, that's going to be 1, then integration of v1, that is integration of minus cos x, that's going to be minus sin x, right? The next term will be second order derivative of x. First order derivative of x is 1, then again if you differentiate it, it's going to be 0. So next term will be equal to 0. So hope you have understood this. So that's why what we have got minus x cos x plus sin x. That is what we have got, integration of this. So what we have got, integration of x sin x dx is equal to, we have got minus x cos x plus sin x, right? So therefore a naught will be equal to, so here we have 0 to pi, right? So 0 to pi, so that's why 2 by pi within square bracket x cos x plus sin x, we are integrating it from 0 to pi, right? So now put the upper and lower limits, then what you will get. So let me go to the next slide. Let me copy this step. Let me go to the next slide. So here is the last step we have got. So this is a naught. So what if you put the upper limit 2 pi, if you put the upper limit pi here, minus pi cos pi plus sin pi, right? And if you put the lower limits 0 into cos 0, right, that's going to be 0. Okay, when you will put x is equal to 0, these things will be also 0, this thing will be also 0. So that's why putting the upper and lower limits. So this is the result we have got, and sin pi is equal to 0. That's why our result going to be equal to 2 by pi minus pi. Cos pi is equal to minus 1 to the power 1, that is nothing but minus 1, right? So cos pi is minus 1, and this is going to be 2 by pi into plus pi, and pi gone. So a naught is equal to 2. We have got the value of a naught is equal to 2, right? So hope you have understood this. Now let's find an. How to find an? Okay, so we have got a naught, that is equal to 2. A naught is equal to 2. Now let's find an. Okay, what will be this? Let me go to the new slide. So this is the formula we're going to use to find n. So here the function, given function f of x is x sin x. So that's why it becomes 2 by pi 0 to pi x sin x cos nx dx. That's what we gonna have, right? So this is what we have got. So an we can write here 1 by pi integration from 0 to pi. Let me write the 2 inside this. Okay, then what you will get, you're gonna have x 2 sine, let me write the cos first, 2 cos nx sin x here dx. So just what we have done here, just I have written this 2 with this, right? So that's how we have got this, and here we're gonna apply this formula. 2 cos a sin b is equal to sin a plus b minus sin a minus b. Okay, so here we're going to take this as a and this one as b. Okay, and if you apply this formula, then what are you going to have? Then 1 by pi 0 to integration x, then you're going to have cos, sorry, not cos, sin. So here a plus b is nothing but nx plus x. So on taking x common, you're gonna have this n plus 1 into x, right? Then minus sin a minus b, that means you're gonna have nx minus x, and if you take x common, then you're gonna have n minus 1 into x, right? That's what we're gonna have. This is dx, right? So till now I hope you have understood this. Now let's find the next step. What gonna be the next step? What we should do here? So here again we're gonna integrate this. Let me integrate this one separately. Integration of x sine n plus 1 x minus sine n minus 1 into x dx. Let me integrate this. So how to integrate this? Again we're gonna apply this formula. Integration of u v1 minus u dash v2 plus u double dash v3 and so on, right? So I have already told you the meaning of v1 is nothing but integration of v. So here you have to take this one as u and this one as v, right? So integration of v2 is integration of v1, right? And u dash means derivative of u, first order derivative of u, and u double dash means second order derivative of u, right? Second order derivative of u, right? So you can say derivative of u dash, you can say derivative of u dash, right? And so on. So hope you have understood these things. Now apply this formula here, then what you will get. So here you can see, as we have here u is x, you can you can find only these two terms, because after if you find a u dash, then you will get here 1, okay, and if you find u double dash, that gonna be equal to 0. So third term will be 0 in this case, okay. So we're gonna get only first two terms. Here our result will be this terms only, these two terms, okay. If you integrate this, so now you see this result will be equal to, so u, that is x here, then integration of this v, that's going to be here, you can see integration of sine n plus 1 x, that's going to be minus cos of n plus 1 x divided by n plus 1, then minus, then again integration of this will be minus cos of n minus 1 into x divided by n minus 1, right? That's what we have got. Then minus u dash derivative of x, right? So that is 1. Then integration of this, then again what you will get, integration of this minus sine of n plus 1 into x by n plus 1 whole square, right? And this let me clean these things, minus sine of n minus 1 x n minus 1 square, right? Now you see integration of sine n plus 1 into x, that is minus cos of n plus 1 into x by n plus 1, and again if you integrate this, then again one more n plus 1 comes here, so that's why n plus 1 whole square. So hope you have understood these things here, why I have written here whole square, right? So now let me copy these things, let me go to the next slide, just let me copy this part. Now let me go to the next slide. So here is the new slide, and this is the result, right? Now you see what was an, this is an, right? An is equal to this. Now let's evaluate the an. So what will be your an now? So here you see, you can see this clearly, that in integration of this part is this, right? So we have got the integration of this. So what we can write here, 1 by pi integration of this part, we have got this result, x integration of minus cos n plus 1 into x by n plus 1, right? And this minus, that's going to be plus cos of n minus 1 by n minus 1, here x, okay. Then again minus just wait, minus sine n plus 1 into x by n plus 1, and this minus plus sine n minus 1 into x by n minus 1, here whole square. I forgot to write the whole square, so bracket close. That is what we have got, and we are integrating it from 0 to pi, right? 0 to pi. So here 0 to pi. For both x equal to 0 and x is equal to pi, sin x is always 0, sin n pi is equal to 0, right? If you put n is equal to 0, then sin 0 is 0, and sin 1 pi, that is sin pi, is also 0. That's why these two terms become 0 for both the upper and lower limit, right? So hope you have understood these things, okay? So just we need to deal with this term only, okay? Because these two will be equal to 0 for both x is equal to 0 and s, this part is equal to 0 for both x is equal to 0 and pi. That's why we're gonna deal with this only, right? So now here you see again, here you can see if you put pi here, then you must gonna have a value, but here you see if you put 0, cos 0 is not equal to 1, but here this term is multiplied by x. So if you put x is equal to 0, this whole term gonna be also equal to 0, right? So that's why let us put only pi. Okay, so if you put pi here, then your value your result will be something like this: minus cos n plus 1 pi by n plus 1 plus cos n minus 1 pi by n plus 1, and minus, if you put the lower limit which is equal to 0, then you're gonna get 0. Okay, 0 into anything is 0, it is gonna be 0, 0 into anything is 0, so that's why it's gonna be 0. So this pi cancel. Okay, so let me cut these things. So you can say that pi cancels. So this is our result. So now this can be written as, let me go to the new slide. Okay, just let me take a new slide. Okay, so here I have told you this is cancel, these two are cancel. So cos n pi is equal to minus 1 whole to the power n. So that's why here you can see minus cos of n plus 1 pi, that must be minus 1 whole to the power n plus 1 divided by n plus 1, and so here it should be minus 1, right? That should be minus 1. Let me go to the previous slide, let me check. Okay, it should be minus 1, that should be also minus, okay, n minus 1, right? So it should be n minus 1. Okay, so here you can see minus 1 whole to the power n minus 1 by n minus 1, right? So we have got this result applying this formula, right? According to this, that cos of n pi is minus 1 to the power n, so that's why cos of n plus 1 pi, that's going to be minus 1 to the power n plus 1, and cos of n minus 1 pi minus 1 to the power n minus 1, right? So hope you have understood this. Now this is defined for only n is equal to n not is equal to 1, right? N not is equal to 1. So we need to find the value of a1 separately, because here you can see, if you go to the Fourier series, here you can see Fourier expansion here. So this n is equal to 1, it starts from 1, so we need to find a value of an. Okay, without a1 we cannot get the correct answer. So that's why let's find a1. Okay, so we have got n, this is the value of an. Okay, that's fine. Bn is equal to 0, we have already discussed it. A naught is equal to 2, we have already got. So now let's find a1. How to find that? Okay, now you can see as an is equal to this. Okay, so let me cut this part. As an is equal to this, right? So that's why this is an, right? So that's why a1 will be equal to, what will be a1? 2 by pi 0 to pi x sin x, because this f of x is nothing but x sin x. Then cos, instead of n there will be 1x means just x, dx, there should be a dx. Okay, so that's how we can find a1. Okay, so now here you can see 0 to pi, here let us make it 1 by pi, then x 2 into sin x cos x dx, and 2 sin x cos x is sin twice x, right? Sin twice x. So that's why what we're gonna have, that a1 is equal to, let me go to the next slide, just wait, sorry, this is not a2. A1 is equal to what we're gonna have, 1 by pi 0 to pi x sin twice x dx. That's what we're gonna have. Okay, so let's go to the next slide. So what we have got, a1 is equal to 1 by pi 0 to pi x sin twice x dx. That's what we have got. So now integration of this, integration of x and sin twice x dx, right? That's gonna be again x, integration of this, that's gonna be minus cos twice x by 2, right? then minus derivative of x is nothing but 1, then integration of v1. So here again I am applying this rule. Okay, so u v1 minus double dash v2, sorry, not double dash, u dash v2, then plus u double dash v3, and so on, right? So here you're gonna have again minus sine twice x by 4. That's what you will get, and in the next term you're gonna have 0, right? That's what we have got. So now let me write the result here. A1 is equal to what we have got, 1 by pi, and here minus, or you can write x into, sorry, just wait, minus x cos twice x by 2, and minus minus plus, this minus it becomes plus sine twice x by 4. That's what we have got, and we are integrating it from 0 to pi, right? So for pi and 0, for both the value, this term will be 0, right? Because sine n pi is equal to 0, and if you put n is equal to 0, sine 0 is also equal to 0. So that's why we're gonna deal with this term only, right? In that case, what you will get, right? If you put the upper limit here, you're gonna get minus pi cos twice pi by 2, and if you put the lower limit here, x into 0, 0 into anything will be equal to 0, right? X will be equal to 0. So that's what you have got. So here you can see clearly that this pi cancel, right? And this is minus 1 by 2, and cos twice pi is nothing but minus 1 whole to the power 2. So that's why that's going to be plus 1. So we have got minus half, right? So we have got a1, right? So now here you can see, now let me go to the new slide. Here you can see this is the Fourier expansion of the given function. In this case our given function is nothing but, so let me write this one. So our given function is nothing but x sine x, right? So that's what we have got. So we have got the value of a naught. A naught is equal to, we have got 2, right? If you go to the previous slides, that this is 2, you can see. Then an, this is our an, and this is a1. Here you can see a1 is equal to this is minus half. So we're going to use these values. A naught we have got a1 is equal to, we have got minus half, bn is equal to 0. Okay, then an is equal to what we have got, an is equal to, so this is the value of an, that is what we have got, an, right? So that should be minus 1. Okay, this is an, right? So using these values in 1, right? So let me clean these things, just wait, let me write using the values of a naught, a1 and an in 2, this 2, right? So what we will get, here you can see this is a naught by 2, so x sine x is equal to, a naught is 2, so here we're gonna have 2 by 2, right? Then here for n is equal to 1, what we're gonna have this its value. Here we have to put a1 is equal to this minus half, so that's why, so here we have to write minus 1 by 2 a1, then cos nx means cos 1x, so we can write cos x. Then for n is equal to 2, then what going to be this term, right? So for, we know the value of an is this, so just put 1, 2 and 3. So here you can see, if you put 2, n is equal to 2 here, you can say. So this part an is given by this expression. If you put here 2, then what you will get? If you put here 2 plus 1, and here 2 minus 1, and this is 2 plus 1 and 2 minus 1, then you're gonna have, first let us deal with this part only. So if you put 2 here, then you should get this will be 3, so that minus 1 cube will be minus 1, and minus 1 into this minus, that's going to be plus, right? And plus 1 by 3, and here we have cos nx, so we are putting n is equal to 2 here, we're going to have cos twice x, right? We're going to have cos twice x. Then if you put if you put n is equal to 3 now, after putting 2, if you put n is equal to 3, then what you will get? For n is equal to 3, this minus 1 minus all to the power 3 plus 1, that's going to be 4, and minus 1 to the power 4 is plus 1, then minus into plus 1, that's going to be minus 1, right? Minus 1 by here putting 3, you will get 4, minus 1 by 4, minus 1 by 4, and now we are putting n equal to 3, so here we're going to have cos twice x, right? Then if you continue this process, then you will get again 1 by plus 1 by 5 cos 4x, then minus 1 by 6 cos 5x, and plus 1 by 7 cos 6x, and so on, right? Dot dot dot. Now that's how we're gonna have. Okay, just wait, let me write these things here. Now you see, now let us deal with this. Okay, let me put 1 2 3, n is equal to 1 we have already done. Putting 1 we have got this term only, so putting 2 3 4 in this term, what will be the values we're going to have? Let me show you plus. So if you put n is equal to 2 here, then what you're going to have? 2 minus 1 is 1, so minus 1 to the power 1 is minus 1. So first term we're going to have here minus 1, then cos twice x, right? And if you put here 3, after putting 2, if you put here 3, then you're going to have 3 minus 1 is 2, then x is minus 1 is square, that's going to be plus 1, plus 1 by 2, that is plus half, then cos thrice x, right? Cos thrice x. Then again you're going to have minus 1 by 3 cos 4x, right? Then you're going to have plus 1 by 4 cos 5x, and similarly cos minus 1 by 5, then you're going to have cos 6x, right? Cos 6x. Then you're going to have plus 1 by 7, then you're going to have cos 8x. Sorry, I made a mistake here. That should be 6, then cos 7x, right? And so on. Then minus 1 by 7 cos 8x, and so on, right? That's how we can evaluate this, right? So hope you have understood this. Now let me copy these things and let me go to the next slide. Okay. Now you can see that x sin x, so 2 by 2 is equal to 1, right? Minus half cos x. So what if you take common cos twice x, then you're gonna have 1 by 3 minus 1 cos twice x. Then if you take cos thrice x common, then you're gonna have minus 1 by 4 plus 2 cos thrice x. Similarly, if you take common 4x, then you're gonna have 1 by 5 minus 1 by 3 cos 4x, and then if you take cos 5x common, then you're gonna have minus 1 by 6 plus 1 by 4 cos 5x. And similarly, if you take cos 6x common, then you're gonna have plus 7 minus 1 by 5 cos 6x, and you can continue this way and so on, right? So now you see, if you simplify this, then what you're gonna have, x sine x is equal to minus 1 by 2 cos of x, right? So yeah, you're gonna have, from here you're gonna have minus 2 by 3 cos twice x. Then from this 2 you're gonna have minus 1 by 4, right? Minus 1 by 4, because there's gonna be 4 minus 1 plus 2, that's gonna be minus 1 by 4, right? Minus 1 by 4 cos thrice x. And in the next term, what are you gonna have? Minus 2 by 15, minus 2 by 15, minus 2 by 15 from this term. So we have got cos 4x. Then just wait, let me do a little bit of adjustment for, as I need more space. Okay, just what I have done here. Okay, now you see plus, then from this two, what we're gonna have, I think minus 1 by 12, minus 1 by 12, yeah, minus 1 by 12. Okay, LCM of 6 and 4 is 12, right? So minus 1 by 12, then cos 5x. Then next term will be, you can see, if you take LCM of this two, then you will get minus 2 by 35 cos 6x. That's what you're gonna have, right? This is our next term, and so on, right? That's what we're gonna have. Now let me copy this result and let me go to the next slide. So this is the result we have got. Okay, so this is the Fourier expansion of the given function x sin x. This is the Fourier expansion of, so this is the required Fourier series. Okay, now we need to prove this one. Here you can see, you see the question. So we need to show this one now. Okay, so just one more part is here. So in order to show that, just put x is equal to pi by 2. Putting x is equal to pi by 2, then what you will get? If you put pi by 2 here and here, then pi by 2 sine pi by 2, which is equal to 90, is equal to 1 minus 1 by cos pi by 2, then plus minus 2 by 3, then cos 2 into pi by 2. If you put here pi by 2 here, then 2 to cancel, so you can write here cos pi, right? You can write here cos pi. Then in the next term, again minus 1 by 4. If you put here pi by 2, then you will get cos 3 pi by 2. Then in the next term, plus minus 2 by 15. Then if you put here 2 pi, then you're going to have cos twice pi, right? Then in the next term, minus 1 by 12, you're going to have cos 5 pi by 2. Then in the next term, if you put here pi by 2, then what you will get? Minus 2 by 35 cos 3 pi, right, and plus so on, right. That's what we're gonna have. Now you see here cos 90 is 0, and this one will be cos pi plus pi by 2. Again it gonna be equal to 0, right. Similarly this term will be also 0, this term will be also 0, right, and we're gonna left with these terms, right. Now so what will you get? So now let me copy these things again and let me go to the next slide. So this is what we have got. So pi by 2, cos pi by 2 is 1, sorry, sin pi by 2 is 1, then we have got minus 1 by 2, sorry, cos pi by 2 is 0, so we have got this thing is 0, this term we got 0. Then again minus 2 by 3, cos pi is minus 1, right, then plus this is gonna be 0, then again we have got minus 2 by 15, cos 2 pi. So here you can see, as we have here 2 pi, so that should be minus 1 to the power 2, and in the next term we should get minus 2 by 35 minus 1 to the power 3 and so on, right. That's how we have got. So here pi by 2, 1 plus 2 by 3, then it's going to be minus 2 by 15, then it's going to be plus 2 by 35 and so on. If you multiply both sides by 2, then you're going to have pi is equal to 2 minus plus 4 by 3, then minus 4 by 15 plus 4 by 35 and so on, right. So that should be minus, alternatively plus and minus sign. Okay, now let me go to the new slide. So here is the last result we have got, and if you simplify this, what you're gonna have, pi minus 2 is equal to 4 by 3 minus 4 by 15 and plus 4 by 35 and so on, right, minus dot dot so on. So divide both sides by 4, then you're gonna have pi by 2 by 4 and here 1 by 3, then minus, and 15 can be written as, so 3 can be written as 3 into 1, 15 can be written as 3 into 5. So let me write this, so 1 into 3 minus 4, 3 into 5, then plus 5 into 7 and so on. That's how we will get. So this is supposed to be 1, sorry, okay, because we have divided both sides by 4, so this is proved. Because if you see the question, that is what we needed to prove. So here you can see, this is we need to prove, right. So you can write this way as well. So here you see, just simply you can write this way, 1 by minus 3 plus, sorry, not plus, minus 1 by 3 into 5, then plus 1 by 5 into 7 minus dot 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 so on, which is equal to pi by 2 minus pi minus 2 by 4. That is what we needed to show. So hope you have understood. As I have mentioned earlier that how to get the answer of this question, pi square by 6, I'm going to show at the end of the video. I will paste the photo of its solution. So that is it. Let me show you. So here you can see this is the function f of x plus x square in this interval. So if you expand it, if you express it in the form of Fourier series, then you can prove this, right. So this is the solution. I'm not going to explain here, just I am giving you the solution here. This is only 1 marks question, that's why I'm not explaining this. So here you can see sum of this series is pi square by 6. Okay, so if you don't know, if you have no idea about Fourier expansion, you can watch my videos on a Fourier series given in the description box, links of the playlist. I have mentioned there Fourier series. And link is there. Okay, so you can watch all the videos, then you will get the idea. Okay, so now remaining questions will be solved in the next videos. Okay, so wait for the next part. So stay connected. Thank you for watching. Do subscribe my channel, also share with your friends. See you in the next video. Bye.